Hey guys, I'm back with a new video. So in the previous video, we'll learn about different types of methods based on which we can differentiate our machine learning models. So continue forward from that point, let us discuss how we can differentiate between machine learning models based on the type of variable which I discussed in the previous video. That is, if the output variable is continuous in nature and you can quantify it, then you're working on a regression problem in that case. Otherwise, if your output variable is discrete in nature, then your problem is a classification problem. So if you haven't watched the previous video, it is highly recommended that you watch that video first before starting with this one. I have explained some very important things in that video that can make your understanding more concrete in this video. So enough of talking, time to come to the topic that I will cover in this video. In this video, our main agenda is to start with simple linear regression. Simple linear regression. I will give a brief overview about straight lines concept, and then we will directly move to simple linear regression, and lastly we will discuss about the problem and dataset that we will work with. Okay, now let us start with the regression. Now, as I covered in the previous video, that regression is a type of supervised learning technique. Supervised learning technique. And we know that for supervised learning, you need an output variable response, or in other words, labels are required for training our regression model. So you do require labels for training your model, okay? So let us proceed. So let us first cover the concept of straight lines. Straight lines. Now coming to straight lines, we know from mathematics that every curve has some mathematical form in terms of an equation that represents it, and every mathematical formula or equation in turn can be described using some curve. Now if I talk about a straight line is also something that has a functional form. So a straight line looks something like this, and it also has some functional form, some mathematical formula. You have an equation for it, and each and every point that basically passes through this line represents a coordinate, or you can say a pair, which is x comma y, where x is your independent variable and y is your dependent variable. So the x coordinate is represented along the x-axis, and y is your dependent variable that you have along the y-axis. So for each value of x, there is a corresponding value of y. So suppose this is your x1. For this x1, you have a certain value of y. Okay, say y1. Now the general equation of a straight line is of the form y is equals to mx plus c, where m is the slope of the line. So you can say m as slope of your line, c is some constant, x is your independent variable, and y is your dependent variable. Now the most important parameters here are m and c. Okay, these are the very most important parameters using which you can tune the position of the line, and for different value of slopes and constant you can get various lines. So using the two-dimensional space and using different values of slopes and constants, you can get infinite lines in the plane. So let me show you. Like this, we can have multiple lines going in a two-dimensional space for different values of m and c. So if you tune the values of m and c, you will get different lines. Okay, now to distinguish one line from another, you basically need these two parameters, namely the slope of the line, which is m, and the intercept that this line is making with the y-axis, which is denoted using c. Okay, so if I take this line into consideration, this one, you can see this is making some intercept. So I will explain what is intercept in general, so you can see this as c. So let me draw this in a fresh diagram. Okay, so if this is our line, okay, then this represents your intercept. See, I will tell you the meaning of intercept. So first you need to understand that the slope of line is defined as the change in y upon change in x. Okay, so suppose we have these 2 points. This point is represented as x1 y1 and this point is represented, say, p and q, and we have this as x2 y2. Now if I talk about the slope of the line, can you tell me for these 2 points what is the change in the values of x? So let me show you this. Let me project this down. You can see we have x1 here and x2 here. Okay, if I take this into consideration, this distance, okay, so you can see that the point P and point Q are at a horizontal distance of x2 minus x1. Okay, and if you are here, then you can see that along the vertical axis, along the y-axis, P and Q are at a distance of y2 minus y1. So this is the change along the y-axis, and x2 minus x1 is the change along the x-axis. Okay, now the slope of the line is defined as the change in y upon change in x. So we can say slope in this case, which is m, is equals to y2 minus y1 upon x2 minus x1. Now more the steepness of the line, more is the slope of the line. Okay, so if I talk about steepness, let me show you this with another diagram. Like if we have this line and we have one more line which looks like this, you can see this line has a lower steep, okay, and this line has a high steepness. So higher the steepness of your line, more will be the slope of your line. Okay, now let us talk about the concept of intercept. So let me clear up my screen. And next concept for straight lines is intercept. Now intercept is nothing but it tells us what is the value of y when x is 0. Okay, again let us see this with the diagram. So if your x value is 0, okay, so you are at this point, what will be the value corresponding to this y? Okay, so this is your intercept. So it basically is telling you what is the value of y when x is 0. So you have the equation y is equals to mx plus c. You plug in x as 0, you get y is equals to c. Okay, so this is represented as 0 comma c, and your this point is your origin 0 comma 0. Now on plugging x as 0 in the straight line equation, whatever value you get for y is known as the value of intercept. So I think a brief refresher on the concept of straight lines must be crystal clear to you guys. So let us now discuss our main topic of the video, which is linear regression. So let me clear the canvas. And simple linear regression. Now linear regression in its most simple form is one of the types of regression algorithms, though we have multiple other regression algorithms as well, which I most likely will go over some of them in great depth in coming videos. So in simple linear regression, you need to understand that we have only one input variable and one output variable. So you have one, okay, you have one input variable and one output variable. Now simple linear regression can be represented using the equation y is equals to m0 plus m1x, where y is your output variable, x is your input variable, and m0 and m1 are known as the parameters or coefficients of your model. Okay, so m0 and m1, these are coefficients of your model. or you can say parameters of your model. Now, if we relate the equation of our simple linear regression, which is this one, with the equation of the straight line that we discussed previously, which was y is equals to mx plus c, you can easily deduce that m0 is equals to c and m1, this m1 is equals to m, which is the slope of the line. Now, since we are trying to estimate a set of parameters, which is m0 and m1, in order to arrive at the equation or the functional form of your model, this technique falls under the parametric method that we discussed in one of the previous videos. So if you haven't checked out the video on different types of machine learning models and how to differentiate between them, the link for that can be found down below. Now, this technique, as I discussed in the previous video, falls under the parametric method, so definitely check out that video. So this was all about the video on regression, and in the next video we'll discuss about the problem and dataset that we will work with using simple linear regression. We'll also start with the implementation. So if you like the video, do give it a thumbs up, subscribe to the channel, and please share the channel with your friends and colleagues, and I will see you guys in the very next video.